like 20 years, no, 10 years ago. So a long time ago already. So WebKit, for those of you who don't know about it, it's a web engine that provides a high-level API that allows native applications to embed the web in native manner. And with that, you can build web browsers, of course, but any kind of application where you want to load a website. And what things we do quite a bit is set-top box UIs as well, and user readers. You can invent many new things. And you have various layers, and at the platform level, we have ports. So where like companies build the specific integration with their platform, so they can ship WebKit in their product, in their hardware. So we have Apple projects, the Sony PlayStation also has a port, and then on the Linux desktop we have a GTK port, and then for embedded platforms we have a thing called WPE, and then there are other things for Windows and JavaScript only, if you only need JavaScript. So I want to address the elephant in the room. If you think about it, many browsers nowadays, most, even the ones not based on Chrome, use the WebRTC. So it's good, I think, to wonder like how sustainable that is. Is it really a situation we want to stay in? Yeah, something to think about. Of course, you might not know it, but you can already use WebRTC in WPE and WebKitGTK. It's just not enabled by default. You have to build it yourself, and there are various reasons why we don't enable it by default. Licensing reasons with boring SSL, which cannot really be shipped for GPL applications. The footprint in tables is quite high. That's not really a big issue, but it's one. And then, as we use GStreamer, we have to integrate with decoders and encoders. We did some integration for decoders. But for encoders, it's not supported. So right now, we can do hardware accelerated encoding with the WebRTC. And also, as I said, we also already use a multimedia framework. And the WebRTC itself is kind of a multimedia framework already. So it's kind of duplicating one where we have one already. So I think it makes sense to keep the one we have already. So yeah, let's talk about GStreamer. Quick introduction. It's a multimedia framework. It's more like a data processing framework where you build graphs, pipelines we call them, where data flows, and you have filter elements, and you can like do processing with that. It's quite cool. It's deployed in many different kind of situations. The space station is one. There's a robot there using GStreamer. It was also used in the LEGO project to detect gravitational waves, like to do the data processing of that information. And yeah, many plugins available for many platforms. And check out tomorrow, there's a talk about it, the State of the Union, in the Open Media Dev Room. So a quick example of a GStreamer pipeline. On the left, you have the file source, which will read a file, and then you can like demux it if it's a case of an OGG file, and then decode and render with the things on the right side. So data flows from the left to the right. Then GstWebRTC, it's two things. It's an element, like the ones I showed before, and it's also a library. So the element can be added in pipelines, and then you can have you have signals and properties to use to interact with WebRTC. So, for instance, to do the ofference stuff, or to add ICE candidates, and so on. So, and then there's a library called libGstWebRTC, which like defines classes and objects API that you need in your application to interact with WebRTC bin. And then for the transport, we use a library called libnice that's also in charge of doing the connection establishment. So the current status of the integration of GstWebRTC in WebKit. So we have many pipelines. One of them is for capture devices. Another one is for the streaming, the encoding and streaming, and also decoding if you have incoming tracks. And also we demonstrated that we can do zero-copy encoding directly from a webcam to RTP payloader, which is quite cool. And then when you receive streams, they are like routed to a different pipeline we have for playback, for the video element, for instance. So we have at least 3 different pipelines for a single plug connection. So for stream capture, we have one pipeline, as I said, and then you have to handle the permissions. For screen capture, you have also to handle permissions because most of the time you're on the Linux desktop, you have to interact with things we call the desktop portal. So we have one permission in WebKit and one at the desktop level. Eventually, we plan to improve a bit on that. And then we interact with PyPria usually on Linux, and it's quite nice because we get DMA buffs, and we can like pass that directly to the encoder. The media stream handling, we have a custom element for that called, it's the source element, so the thing you would put on the left side of a pipeline. And it can be used to interact with capture pipelines, the canvas video elements, and also incoming streams, like when you want to play an incoming stream, an incoming video or audio stream. And then if you think of a media stream, like it can have one or multiple tracks. At the GStreamer level, those correspond to pads. The pads are the things we use to connect elements together, and that's also how we pass data between elements. So here I have a really simple example. It's really simplified because the pipeline can be really big. It wouldn't fit on one slide, so I had to simplify a few things. On the left side, you have a source element which is doing capture on the capture device. Then you can encode and then RTP payload. And then you pass that to WebRTC bin, which does a lot of things, and it's sending data over the network. And then if you receive an incoming track, you have a source pad that's created by WebRTC bin, and then we can be notified of that pad and connect to a media player. So yeah, the pad connection is, WebRTC bin was designed to follow the spec. So if you know about WebRTC, you can quite easily use WebRTC bin already. You have signals corresponding to all the different steps of the spec. And yeah, it was quite natural to integrate into WebKit. We had some issues, but in general, it was quite easy to have a basic prototype. And also, the GstPromise interface integrates quite well with WebKit's Promise asynchronous API. So, for instance, on the JavaScript side, if you want to if you receive a track event and want to connect to a video element, you would say video element.source. And then in WebKit, what it does is that it would create a media player and then use the media stream source element that I introduced a couple of slides before and connect that into the pipeline, and the data would flow naturally to the decoders and to the sink. Then there are more things like statistics, data channels. All this is already supported by GstWebRTC, but the statistics, since WebRTC bin only knows about the streaming and doesn't know about the encoder or decoder itself, we have to augment the statistics with information we have in our pipeline. So there's a bit more work to do on that. And then data channel was also quite easy to integrate because the API is like one-to-one mapping, and it was really, really nice to integrate with. There are more things. Those two things are not implemented by GstWebRTC. We had to do it in WebKit. Replace track, so we like switch between one media stream track to another. That's basically like GStreamer pipeline manipulations, basically. And then we had to add support for legacy offer options because we had some application that needed it. I will talk about that in a few slides. Yeah. So yeah, the use cases. Obvious ones, video conferencing. We are not there yet. We have some basic prototypes for a couple platforms, but they are not really fully functional yet. So we did some work on Jitsi, on LiveKit. Yeah, still work to do there in that front. But I want to talk about a couple more things. So cloud gaming is one really interesting use case we've been working on. We got Amazon Luna to work on set-top boxes, integrated with hardware decoders. And you can also, if you use Amazon Luna, you can stream to Twitch your webcam. It's not really supported yet by our ports, but eventually we will get that working. I had a demo, but maybe I don't think I will have time. Maybe at the end I will show it. Another use case we worked on is pixel streaming. We had a a contract with a company called Zoo. They have an open source CAD application called KittyCAD, and we made it work in Linux with WebKitGTK. We fixed a couple of things in WebKit for that, and it was really interesting. I also demo, but maybe later. It was quite interesting because they used data channel for the pointer events for the integration with the model, and I thought it was an interesting use case for WebRTC. Ongoing work, we have quite a few things. We want to focus a lot on dev tools because, as you might know, in WebKit and in Safari, the dev tools are not as good as in Chrome, so we want to improve a bit on that. Maybe you know there's a feature in Web Inspector called Gather WebRTC logs. It's really, I don't think many people know about it, but it's there and it's really basic. So we want to build up on that. We have made a backend. We call it DevTool backend, which when you enable it, it will emit a JSON stream. You can do live graphing or post-mortem analysis of your WebRTC connection with that. Right now it's enabled with an environment variable, and I've built a really basic front end for that. You might recognize the graph canvas from Chrome, so I reused that to make the graphs. So that's currently like a third-party project. Eventually, we'd like to have it integrated in WebKit itself using a custom URI protocol or maybe an inspector. More things we work on currently, network condition simulations. So we want to improve our packetless story like FEC, RTX, and these things. So being able to simulate conditions is really nice, and we added that support recently. We have the basic infrastructure for simulcast. SVC, like VP8 temporal scalability works, but it's not working yet for VP9 and AV1. So some work will be needed in GStreamer itself for that. Hardware encoding, we made some early experiments already on Raspberry Pi and on desktop, and we got it working, but it's not fully upstream yet. And then there's other things such as end-to-end encryption. The story there to me, if how exactly we should implement that, because you can encrypt in various ways, and we need to work out on the implementation details regarding that. We want to improve also our sandboxing story, because WebKit is split in various processes for security reasons. Right now we have everything working in the web process, which is not really good for security, like the capture device access is done from the web process. Eventually we want to improve on that. On embedded platform we will have to continue with that, but on the desktop we have to use we could use a portal called the camera portal, sorry. And again, regarding sandboxing, right now we also have to disable the sandbox in the web process to be able to set up a peer connection, because we don't have the UDP, the RTP traffic routed to the network process. So it's still some work we plan to do with a new ICE implementation called LibreICE, which is written in Rust, and is quite a cool project. And eventually we plan to integrate that new project into WebKit as a ICE transport backend. That's it. That's your questions.
For your WebRTC things and sources, do you support the RTC feedback events? And if so, is that end-to-end, or is it just between hops in the pipeline?
Sorry,
RTCP feedback, for what I was saying about getting feedback about the quality of the stream.
Yeah, so the question is about RTCP feedback. Yeah, if we support that or not. I think it's supported in WebRTC bin. Yeah. The RTP stack in GStreamer is quite complete. It's really awesome. There's many things there supported, and it works quite well as well. So. Yes?
Have you explored perhaps using the higher level elements WebRTC sourcing from the Rust plugins? Because that came after you started the project.
Yeah.